Every object-oriented language gives you three keywords that most developers learn once, use by habit and never think about again: public, private, protected. But these three words are not just syntax. They are the entire reason your code does not collapse under its own weight the moment a second developer touches it. In this video, we are going to build a real mental model of what access modifiers actually are, why they exist, and exactly when to reach for each one. Imagine you write a class called bank account and you leave the balance field completely public. Now any line of code anywhere in the entire codebase can write bank account. Balance equals negative 999,000. There is no validation, no guard, no audit trail. The field is just exposed. This is not a hypothetical. This is what code looks like without access modifiers, and it is genuinely terrifying at scale. Access modifiers are the contract between a class and everything outside it. They decide who is allowed to see your internals and, more importantly, who is not. Public means exactly what it says. Mark a field or method public and any code anywhere can reach it. A class in the same file, a subclass 3 packages away, a completely unrelated utility class in a different module. All of them can call it. Public is the right choice for your API surface, the methods and constants you actually intend for the outside world to use. Things like a deposit method on bank account, a draw method on a shape, a factory method that constructs object. If the whole point of something is to be called from outside the class, make it public. Private is the strongest lock. A private field or method can only be accessed from inside the class that declares it, not from a subclass, not from another class in the same package, only from within the declaring class itself. This is exactly right for implementation details. The balance field on bank account should be private. Nobody outside the class should be able to set it directly. The class itself manages it through controlled deposit and withdraw methods. Private fields are the reason you can refactor the internals of a class without breaking everything that uses it. Protected sits between the two. A protected member is visible to the declaring class and to any subclass that extends it. So if animal declares a protected field called age, then dog and cat, which both extend animal, can read and write age directly. But a completely unrelated class, a stranger that has no relationship to animal at all, gets blocked. Protected is the right tool when you are building a base class that is designed to be extended, and you want subclasses to have direct access to inherited state, but you do not want that state exposed to the general public. Here is the deeper reason all of this matters. When you make a field private and expose it only through methods, you gain something called encapsulation. Take a simple counter class. If the count field is public, any code anywhere can set it to -5 or null or a million. There is no invariant you can enforce. But if count is private and the only way to change it is through an increment method, then you have a guarantee. Count can only go up. You can add logging in one place. You can make it thread safe in one place. The class is now a unit with behavior, not just a bag of data. Most common real-world pattern that encapsulation enables is the getter and setter pair. You make a field private, then expose a getter that simply returns it and a setter that validate before assigning. The temperature class is a perfect example. The Celsius field is private. The setter checks that the new value is above absolute zero before assigning it. If it is not, it throws an exception. That validation gate lives in one place. It runs every single time. No caller can bypass it. You can also add logging, change detection, or lazy computation inside the getter without touching any calling code. So which modifier should you actually reach for? The answer is almost always private first. Start by making everything private. Then ask whether subclasses genuinely need direct access to this field. If yes, relax it to protected. Then ask whether code completely outside this class hierarchy needs to call this method. If yes, make it public. Going in that direction from private outward keeps your class boundaries intentional. The mistake is going the other way, starting everything public because it is convenient and never having a reason to change it. Access modifiers are not a ceremony you perform to satisfy the compiler. They are a design tool. Every public you write is a promise to every caller that this method is stable and intentional. Every private you write is a boundary that lets you change the implementation without breaking the world. Think of your class as having two surfaces. The public surface, which is what you promise to the outside world, and the private interior, which is how you actually keep that promise. Keep the public surface small, intentional, and stable. Keep the private interior free to change. That is how classes stay manageable as systems grow. Thanks for watching.